Okay, welcome back, guys. We had example 4 left from section 3.6. And also, after doing this one by hand, I'll show you how you can do it using matrices as well. And the only difference is when you go to set up your coefficient matrix A, if any of those variables are missing, you just give them coefficients of 0, and that's it. Okay. But in any case, alright, let's get started. It says the sum of three numbers is 55. The difference of the largest and smallest is 49, and the sum of the two smaller numbers is 13. So find the numbers. Alright, well, a picture is not really going to be apropos here. So let's go ahead and define our variables. So again, we're talking about three unknowns, three different numbers, right? So I'm just going to continue to use X, Y, and Z. Oh, I was wondering why my stylus was not working. Didn't have it plugged in. So I'm going to let X represent the largest number. Y will be my middle number again. And then Z will be my smallest number. Okay. And guys, this particular problem actually does give us all of the information explicitly. This very first sentence, this is your first equation. Remember how I told you you'll typically have one equation that represents something plus something plus something is equal to sum total? Well, that's what this is. The sum of three numbers, or in other words, X plus Y plus Z is 55. Okay, so that is our first equation. And it goes on to say, the difference of the largest and smallest is 49. Or in other words, if we subtract, okay, X is our largest, Z is our smallest, so if we subtract from our largest our smallest number, we should get a difference of 49. That's what that's telling us. And then finally, the sum of the two smaller numbers is 13. Well, the two smaller numbers are going to be Y and Z. So their sum should be equal to 13. So in other words, Y plus Z should equal 13. And on this one, guys, I kind of get lucky because after setting up my three equations, they're all actually in standard form, aren't they? So I don't need to worry about moving any terms around. Okay. So I can go ahead and commence trying to eliminate one of these variables. And I'll go ahead and label these as well, just to be consistent. Now I'm looking here, and I notice I have two X's and two Y's. So I would definitely want to try to eliminate either the X's or the Y's first. Eliminating the Z's is just going to be more work, because you're going to have to combine 1 and 2 and then 1 and 3 again, because the Z is in all three of those equations. So guys, I'm going to arbitrarily choose to eliminate X, and to do that I will combine equations 1 and 2. Okay, so X plus Y plus Z is equal to 55, and then equation 2, X minus Z is equal to 49. Okay. Now, don't be derailed by looking at this and saying, oh, well, I can cancel my Z's. Because remember, Z is in all three of these. You may easily cancel them here, but then you're going to have to turn around and combine 1 and 3 to cancel the Z's. So I'm still going for my X's. But I need them to be opposites. Okay, so I'm going to multiply my top equation -1, or just negative, however you want to look at it. And that'll just change the signs of all these terms. Okay, and I'm going to keep equation 2 as written. And now we can combine these and eliminate our x's. And so now if we add these columns, we'll get a -y. A negative z with another negative z will be a -2z. And then -55 plus 49 is -6. So again, this is sort of like my intermediate equation, but with these, I can now pair this one with equation 3 because it has exactly a y and a z, and proceed to eliminate either y or z. Okay, so I'll rewrite that equation that I just obtained. And now I'm going to pair it with number 3. And guys, if you're noticing this one's going to work out real nice. Nicely, that is, because the y's are already poised to eliminate themselves. Bam. And so -2z plus z is -1z. -6 plus 13 is 7. And if we divide both sides by -1, we get our value for z. It ends up being a -7. Now you may be saying, well, didn't you just say that you need to question yourself as to whether these numbers make sense in the context of the problem? Well, you may say, no, it doesn't, and that's because we tend to think of only positive numbers. Okay, it doesn't say anything about the nature of the numbers. So the smallest number, which z represents, could most definitely be a negative, and it actually is. That's the only way for all of these conditions in the problem to be satisfied. Okay. All right. So now that we know what z is, let's do some back substitution. Okay. All right, what I'm going to do, I could choose equation 2. I think I'll go with 3, though. So I'll recopy equation 3. And I will plug the -7 that I obtained for z in. And this will give me y minus 7 is equal to 13. And so here to isolate for y, I just need to add 7 to both sides. So we get that y must equal 13 plus 7, which is 20. Okay, so that's my middle number. So far these are making sense. Z is the smallest, y is next, and then x should be the largest. And for this one, I'm going to use the very first, even though I could use any of them at this point. Alright, so x plus y, which is a 20, plus z, which is a -7, should equal 55. Well, right here, 20 minus 7 is 13, so we'll get x plus 13 equals 55. And now by subtracting 13 from both sides, we get that x is 42. Okay, and now I'm going to restate down here what I just obtained. X is 42, so that means our largest number is equal to 42. Our middle number is 20. And finally, our smallest number is -7. Alright, now I'm going to zoom out because I want you to see that I could have solved this system using matrices. Okay, so this is my original system right here, and now I'm going to represent the left hand side using my coefficient matrix A. Okay, so capital A is going to be equal to, remember, 3 rows, 3 columns. So for x, y, and z, these all have coefficients of 1. So in my first row, I'll have 1, 1, and 1. And in my second row, I'll have a 1 for the x, a 0 for the y because there is no y term, and a negative 1 for the z. And then for the third row, I'll have a 0 for the x, a 1 for the y, and a 1 for the z. Okay. And then for my coefficient, or not my coefficient, but my constant matrix, it'll just be these corresponding constants: 55, 49, and 33. Okay. And then if you remember, the matrix algebra that's involved in revealing the solution is taking the inverse of matrix A and multiplying it by matrix B. Okay. And then interestingly, guys, after this section we will study matrices a little explicitly. Alright, well the rest of this I have to do in my calculator. So I know I already showed you how to do this, but let me just take this opportunity to reiterate. Okay. Here we go. Alright, so let me go to my home screen. I'm going to go to second, hit my matrix key. I'm going to scroll over to edit because I'm inputting these matrices. A is highlighted, so I hit enter. And I need a 3 by 3. So 3 by 3. And then I'm going to input my coefficients. Okay. There we go. So now I'll go right back to that screen, go over to edit again, go down to B, and input these values for B. And remember, B is now a 3 by 1, 3 rows and 1 column. And the entries are 55, 49, and 13. And now I will hit second in the mode key to quit that screen. And now I just need to tell my calculator to perform this operation right here. So I go back to the matrix screen, but I don't go to edit, I just select matrix A. I hit this inverse key, and I can say times, go back to the matrix screen, go down to number 2, and grab B. Okay, hit enter, and look at what we got. 42, 20, negative 7. Okay, so I just wanted to show you that to be thorough. Now I'll go ahead and write this as a 3 by 1 matrix. 42, 20, and negative 7. Okay. So matrices are really quite powerful, guys, as you're going to see in the next section. They're really neat. They're really interesting. When I was in college, I had to take a course called linear algebra. It's also known as matrix algebra. And it's just a study of matrices. What can you do with them? What are their properties? It's a more conceptual study of them, though. And I actually had to take an advanced course as well, all of which I've forgotten, just so you know. But anyway, I'll see you in section 10.2, I believe it is. Okay.